Raman High School, the pioneer of IIT Foundation in Tri-Cities.
So students, let us have a chart form for all the quantum numbers, principal, azimuthal, magnetic and sphere quantum numbers. N value, L value and M value. Number of subshells, number of orbitals, and number of electrons. Right. So when n is 1, first orbit, you know L will be n minus 1, it will be 0. And M will be 1. Number of subshells will be 1. And that too S subshell. Here 1s orbital. And the number of electrons according to the formula 2n square is 2 electrons. Number of orbitals formula n square. Number of electrons formula 2n square. And when n is 2, what will be L? 2 minus 1, 0 and 1. 0 means S subshell. 1 means P. This is number of orbitals. It is 1 and it is 3. So, number of subshells. It is 2s, and this is 2p. And number of orbitals in this 1 and in this 3 according to this. So number of electrons, 2 square means 8 electrons. In this 2 electrons, in this 6 electrons, totally 8 electrons. And here, when n is 3, L is 2, 0, 1 and 2. 0 means M value 1 means M value 3, 2 means M value 5, and here also 1 and 3. So here number of subshells 3s, 3p and 3d. Number of orbitals in 3s 1 orbital, 3p 3 orbitals, 3d 5 orbitals. And in these 2 electrons, in these 6 electrons, in these 10 electrons, totally 18 electrons. And coming to the 4th orbit, zero, 1, 2 and 3. Here 0 means 1 value, 1 means 3, 2 means 5, D means 7. And according to this, there will be 1 subshell 4s, and this is 4p, and this is 4d, and this is 4f. Here, number of electrons will be 2 into 4 square, 32 electrons. How 32? S orbital will have 2 electrons. P orbital, number of orbitals are 1 in the S orbital. 3 orbitals in the p subshell, 5 orbitals in the d subshell, 7 orbitals in the f subshell. 7, 10, 15, 16. N square is 4, 4 square it is totally 16. 3 square it is totally 9. 2 square it is totally 4. 1 square it is totally 1. And now in the first orbit, in the s orbital 2 electrons, 3 p orbitals 6 plus 2 8, 10 and 14. Put together 32 electrons. So in value 1 first orbit 0, in value 1 number of subshells are 1, that is 1s and 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 5f, and 1 number of orbitals are first orbit 1, second orbit 4, third orbit 9 and fourth orbit 16, and those are in this way. It is 3s, 3p, you will have px, py, pz, dx by dy, z, x square, y square, z square, and so on. This is the clarity what we have got through quantum mechanics. And the last and final topic of the atomic structure is electronic configuration. What is that electronic configuration? Let us see now. Electronic configuration. So, it is the concept proposed by Niels Bohr, based on a theory we call it as Bohr-Bury theory. Electronic configuration is nothing but arrangement of electrons, the filling of electrons from the ground orbital of the atom. Say suppose atomic number of an element is 50. If the atomic number is 50, it will have 50 electrons. Now, in which orbit, how many electrons should be there? In which orbital, where that orbital should be? So, that systematic arrangement in the certain order. So, the filling of electrons from the ground orbital of the atom is called electronic configuration. Once again, filling of electrons from the ground orbit. Ground orbit means first orbit. Ground orbit of the atom is called electronic configuration. This electronic configuration was proposed by Niels Bohr. There are three methods of writing the electronic configuration. First one is numerical method. Numerical method. This you will learn in 6th, 7th, 8th classes. Next is NLX method. This is the universally accepted one. NLX method. N is the orbit number, L is the orbital, and X indicates the number of electrons in that. And the third one is orbital method. Orbital method. So these are three ways you write the electronic configuration. One is numerical method, another is NLX method, and third is orbital method. Let us go into that. So, before going into that, I just revise the definition again. Electronic configuration is nothing but filling the electrons, the systematic arrangement of electrons from the ground orbit of the atom. There are three types of electronic configuration: numerical method, NLX method, and orbital method. So, to write the electronic configuration, there are some rules to be followed. First is Aufbau's principle. N plus L rule. Euler's diagram. Hooke's rule of maximum multiplicity. And Pauli's exclusion principle. Pauli's exclusion principle. This is also called Pauli's rule. Aufbau's principle, N plus L rule, Euler's diagram, Hund's rule of maximum multiplicity, and Pauli's rule. So these are the 5 rules to be followed to write the electronic configuration. And the first 3 rules, that is Aufbau's principle, N plus L rule, and Euler diagram, even though they are different, but the meaning which they give, the information which they give is the same. Let us see Aufbau's principle. What is this Aufbau? The meaning of Aufbau might be it is German word, I think so, German or French word. Aufbau's principle say Aufbau means building up. Aufbau means building up. Building up means when you construct a building, you will construct 10th floor first or first floor first, ground floor first. Naturally ground floor. So Aufbau's principle also says the same. Whenever you fill the electrons, you have to fill the electrons by selecting the lowest energized orbital. And the filling of electrons should take place in the increasing order of the energy of the orbitals. That is the meaning of Aufbau's principle. Aufbau meaning is building up. Building up means you have to fill first lowest one, next lowest one, next lowest one, next lowest one, and so on. So that is in the increasing order of the energy of the electrons, you have to fill first. This is Aufbau's principle. Aufbau's principle may be defined as the filling of electrons in the increasing order of the energy of the orbitals is called Aufbau principle. Right. Come to N plus L rule. This will give you the values which has more energy, which has less energy. Let us take some 5 orbitals. 1s you have, 2s you have, 2p you have, 3s, 3p, 3d, and 4f and so on. Now according to N plus L rule, either this should be filled first or this should be filled first. Let us find out the N plus L value. The N value of this is 1. L value of S option is 0. And the N value of this is 2. L value of this is also 0. Now N plus L value is 1 plus 0, 2 plus 0. So here it is 1, here it is 2. Now N plus L value of 1s is lower than 2s. So we will select the 1s first, then 2s. This way N plus L rule will help us. And not only this, let us take 3D and 4S, 4D, 4P, 4F and so on. Now let us take 3D and 4P. 3D and 4P. Let us take the N plus L value. N value of this is 3. L value of the D is 2 according to azimuthal quantum number. Here N value is 4, L value is 1. Now the N plus L value is 3 plus 2, 5, 4 plus 1, 5. So you have come across the orbitals whose N plus L values are same. Now when the N plus L value is same, you have to select the orbital whose N value is more. See, the N value of 3D is 3 and N value of 4P is 4. Here the 4P has higher N value, so you have to opt 3D first, then 4P. Like that, with the help of the N plus L value, you can calculate all the orbitals values, then we will proceed in selecting which orbital comes first, which orbital comes next. So Aufbau's principle and N plus L value will give the same meaning. And the Euler's diagram, this is beautiful, same meaning, but this gives in a diagrammatic way. And before going to this Euler diagram, let us see the Hund's rule. Hund's rule, I will explain you while writing the electronic configuration, and we will go to this Pauli's rule. What Pauli's rule says, every orbital should accommodate 2 electrons. For example, 1s orbital, it should have 2 electrons. Suppose if it is 2p, there are 3 p orbitals, 3 2s are 6, so it is 2p6. 3d if you take, there are 5 p orbitals, 5 into 2, you will write 10. So like this, every orbital can accommodate 2 electrons only. That is the Pauli's exclusion principle. So, Aufbau's principle says, electrons must be filled in the ascending order of the energy of the orbitals. N plus A value will give you which orbital have what is the value, and the lowest value should be taken first, then next one. Minor diagram also will give you the same. Pauli's rule says every orbital accommodates 2 electrons only. And coming to the Euler's diagram, let us see now. This is very easy and very important to write the electronic configuration. Let us see friends, n is 1. So according to azimuthal quantum number, L becomes 0, 0 means 1s. That means it will have one orbital, that is 1s orbital. N is 2, you will have 2s and 2p. Why 2s and 2p? Because when n is 2, L is n minus 1. N minus 1 means 2 minus 1, 1. So 0 and 1. When n is 3, L is 3 minus 1, this is 0, 1 and 2. And when n is 4, L is 4 minus 1, this is 0, 1 and 2 and 3. Now let us see, n is 3. Then we will have 3s, we will have 3p, and we will have 3d. N is 4, we will have 4s, we will have 4p, we will have 4d and 4f. And coming to n is 5, 5s, 5p, 5d and 5f. So like this it goes. Now the arrow indicates which is to be filled first. Let us see, you can draw arrows. So first you will take 1s. After filling 1s, how many we can fill? 2 electrons, because Pauli's rule says every orbital should be filled with 2 electrons. After filling 1s, you will go to 2. 2s, then after you will go to 2p. After completing 2p, in 2p you can fill 6 electrons because there will be 3p orbitals, 3 2s are 6. You will come to 3s. After filling 3s, then you will go to 3p, then 4s, then you will go to 3d, then 4p, then 5s, then you will go to 4d, 5p, 6s, then you will go to 4f, 5d, 6p and 7s and so on. So this is a beautiful one, very easy. If you can recollect this, if you have idea of this in your mind, then you can simply select first 1s, then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s. And just I'll take 1 minute of your time to see, to cross check n plus L rule. Here, after filling 3p, we have gone to 4s, according to the diagram. Now let us see 3p, 4s. Let us take the n plus L value. N value is 3, L value is 1, p orbital. Here, n value is 4, L value for s orbital is 0. Now n plus L value, 3 plus 1, 4. Here also 3 plus 1, 4. Now 3p and 4s, has same n plus l value. But according to n plus l rule, you have to select first the orbital whose n value is less than the higher one. And that is matched here. First here step, the Euler diagram shows you 3p, then it shows you 4s. So this is Euler's diagram. So dear students, now let us go to the electronic configuration. How to write the electronic configuration of elements. Right. Let us take first 10 elements: hydrogen, atomic number 1, helium, atomic number 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7. You have three methods as we have already discussed. One is numerical method, another is NLX method, third is orbital method. It has one electron because atomic number is 1, so we will write 1. And in NLX method, according to Euler diagram, we have to select the first orbital, that is 1s orbital, and in the 1s orbital, it should be only 1 electron. And coming to orbital method, imagine this is 1s orbital, 1 electron like this. So coming to helium, 2 electrons are there, so we will write first orbit 2 electrons. And in NLX method, you will write 1s2. And in orbital method, you will write first electron, second electron, 2 electrons. Coming to lithium, you said 2n squared formula says 2 into 1 square, it is 2 electrons. So first orbit 2 electrons, but the atomic number is 3. So you will say, we will go to the second orbit, that is 2, 1. And coming to 1s2, after 1s2, you can see the Euler diagram, 2s will come. So you have 3 electrons, 1s2, 2s1. And here you will select 1s and also 2s, 1, 2 and 3. Coming to beryllium, 4 electrons, 2, 4. Here 1s2, 2s2. And here 1s2, 2s2. Coming to boron, there are 5 electrons, 2, 3, and 1s2 we filled, 2s2 we filled. Then according to the Euler diagram, 2p will come. So this is 2p1. And orbital configuration says 1s2, 2s2, then comes the 2p. According to the orientations, we have 3. One is px, one is pz, py, and pz. And 2p1, so we'll select 2p1. Coming to carbon, you have 6 electrons. First orbit 2, you have leftover electrons are 4, so we'll write 2, 4. And coming to 1s2, 2s2, 2p2. So orbital configuration here, 1s2, 2s2, and here comes the Hund's rule. You have 2 electrons, so you have the possibility to write 2 electrons here only. And also you have the possibility to write 1 here and 1 here. And why we should write like this, we can explain with the example of nitrogen. I'll clear this. Coming to nitrogen, atomic number 7. It is first orbit 2, you have leftover electrons 5. So 4 and the leftover electrons are 3, 2p3. Now coming to orbital configuration, 1s2, 2s2, 2p3. So here you see clearly 2p1, 2p2, 2p3. If you feel like this, Ohm's rule will not accept, because Ohm's rule says, what is the Ohm's rule is, whenever degenerate orbitals are available, degenerate orbitals, whenever degenerate orbitals, that means the orbitals of same energy are called degenerate orbitals. Now here, all the 3p orbitals belongs to 2p, px, py, pz. So when 3p orbitals have same energy, then you have to follow the Ohm's rule that they should be half filled first. 1, 2 and 3. Then only it comes to pairing. Now let us see next one. What is the next one? Nitrogen, oxygen, atomic number 8, 2, 6, 1s2, 2s2, 2p4. So 1s, 2s, and coming to 2p4, 2p1, 2p2, 2p3, 2p4. What we did here, first of all, we have half filled them, 2p1, 2p2, 2p3. Then comes to pairing. Otherwise, for oxygen, you have the possibility to write like this, 2p1, 2p2, 2p3, 2p4. So, this is not acceptable, because Ohm's rule says, when you get degenerate orbitals, you first half fill them, then you pair them. So that is what we are doing for oxygen here. 2p4 electrons, so 2p1, 2p2, 2p3, 2p4. This is Ohm's rule. So this is the way you write the electronic configuration. And if you do not follow the Ohm's rule, you will get a confusion regarding the properties of the elements that we will discuss in chemical bonding lesson. So friends, I will just in a gist I will tell you electronic configuration. The arrangement of electrons in the ground from the ground orbit of the atom is called electronic configuration. There is 3 types of electronic configuration as we are writing here: numerical method, NLX method, and orbital method. And the rules to be followed are Aufbau's principle, N+L rule, Euler diagram, Ohm's rule, Pauli's rule. Aufbau's principle is defined as the filling of electrons from the ground orbit of the atom is called Aufbau's principle. It should be filled. The electrons must be filled in the ascending order of the energy of the orbitals. That is Aufbau's principle. N+L rule will give you the values. By the values we can identify which is to be filled first. Then Euler's diagram will give you a descent diagram which you can understand easily. Coming to the Ohm's rule, whenever degenerate orbitals are available, they have to be half filled first and then pairing takes place. Coming to Pauli's rule, every orbital can accommodate 2 electrons only. There is another definition for Pauli's rule that no 2 electrons will have the 4 quantum numbers same. No 2 electrons means in an orbital there should be there is no chance for having all the 4 quantum numbers value same. N value, L value, M value and S value. This comes in intermediate in a detailed way. So Pauli's principle says no 2 electrons will have the 4 quantum numbers same, or otherwise simply every orbital accommodates 2 electrons only. So with this chapter is completed, and some important things I would like to share with you. And this lesson, you have some areas to practice. First thing is diagrams of p orbitals, diagram of s orbital, and diagrams of d orbitals. If you can practice minimum 50 times, then only you will get perfection, because definitely there is a scope for 2 marks question and sometimes 4 marks questions also. Thank you. Read the textbook carefully. There will be reading will be of 3 types. First time reading, second time reading, and third time These 3 times reading will give you one thing, that is check, recheck and double check. When you read first time, you will get some questions. When you read second time, you will have some doubts. You will clarify the first time doubts. In the second time, you will get some perfection. And the third reading will give you double check it is. So wherever there is a possibility of framing the tough questions, there you can perform in a better way. Writing a physical science exam, board exam in 10th class, you have 1 mark questions, 2 marks questions and 4 marks questions and objective type. 4 marks questions and objective type can be attempted by every student, but the difficult area is only 1 mark questions, because you don't have a guarantee that you will get the questions only from back of the textbook, but also within the textbook from any paragraph a concept can be picked and a own question can be framed in 1 mark questions. That's the reason you have to read the textbook 3 times, underline each and every point. Whatever you miss, you will, whatever the doubts you get, you will clarify from your teacher, so that you can perfectly write the annual exams. Thank you once again.